So guys, yesterday, since we had earthquake drill, so we are unable to discuss this lesson 2.8, and it's all about inverse functions. But I let you watch the video at home, right? Did you guys watch video at home? No? Well, anyway, we're gonna discuss this one. So it's gonna be 2.8 inverse functions. Now, inverse functions is not new to you because it was discussed in your Algebra 2, in Mr. Cooper, and in Miss Cruz, right? So what is your idea about inverse function? What to do for the variable x and variable y? Isn't it that you are switching? So, again, the x and y, so it's just a reflection, guys. It's like a mirror. You're gonna have the reflection, okay? So, given function, so a function f has an inverse function or is invertible. So can you please write the word invertible? I'm gonna use red color, so invertible. So if each output value of f is mapped, so the mapping right here is you have coordinate x and y. It's going to be mapped into, the mapping would be, sorry. So from x and y, you're gonna map into y x, meaning we are changing x to y and y to x and solve for the value of y. So in this case, given function, now what you notice on this given function, x plus 2 to the power of 3 plus 3. So this is a cubic function, right? Now, can you still remember the parent function of this, the graph of a parent function? Can you see right here that the graph of a parent function looks like this for a cubic function, this blue color, okay? So, this cubic function is, because of this, that means the behavior of the graph now is being pushed up. How many units? 3 units. And then, where is the slide? To the left or to the right?
To the left.
To the left. How many units?
2.
2 units. So, this is now being pushed to the left 2 units. So, imagine that if this is the original one, so it's being pushed 3 units up and then slide to the left. Okay, Miho, can you refrain from doing side conversations? Listen first here, okay? So this is being pushed 3 units up because of this, and then slide to the left 2 units. And this is now the graph of this particular function, okay? Can I erase this first? So which means we're gonna have to deal on this one. Let's just to approximate this, that this is at the value of x negative 4, the function, when I say function, it's the value of y, is gonna be at negative 5. Okay, so I have to say, when I start at the bottom, if x is negative 4, what is the y? The function is equal to negative 5. Okay, so this is it. And then the next to consider is at the value of x equals negative 3, what is the value of y right here? What is the value of y if x is negative 3? It's gonna be positive 2. Okay, so negative 3 and it's gonna be 2. How about if x is negative 2, what is the value of y?
3.
Okay, y is 3, so at negative 2, y is 3. How about at negative 1, x equals negative 1, what is the value of y? It's gonna be 4. Okay, so negative 1 is 4. Now Are this clear to you guys? And where do the graph goes? Goes to infinity, right? So both up and down goes to infinity. Now, since we are going to map this one, the mapping should be xy and then yx. So what happens? We are switching now the x and y, right? So this becomes now 4, 3, 2, and -5. And then the y values now are, or the inverse, we have -1, -2, -3, and -4. Okay? Clear, guys? Now remember, in this case, if we reflect, there must be a symmetrical line or line of symmetry. So the line of symmetry right here is this one. So in a form, so this line of symmetry is y is equal to x. So this graph is being reflected right here to the other side. Okay, this is the line of symmetry. Now, we all know that at the start, the point is this is -4, -5, right? So what is the inverse of this one? -5 and then -4. So where is that -5? The value of x is -5, right? So can I choose blue color for this, green color for this one? Okay, x is -5, y is -4. So where is it? It's gonna be right here. Okay. Okay, guys. And what's next? At x equals 2, what is y? -3. So at 2. Okay. -3 right here. Next, x is equal to -3, 3, y is -2. So x equals 3, y is -2. What else? The last one. Value of x, 4, and then when I say y, it is the inverse right here, okay? -1. So 4, -1. Look, this goes to infinity, to the y, right? Therefore, it's gonna be to the x right here is infinity. Do you get me? Now look at this one. This is a curve. Therefore, if this goes out, so this goes out also. Get me? This is in. Okay. So that means the graph goes that way. You're gonna connect this. More or less, it's similar already, right? And then this is the line of symmetry. So this is the graph now of the inverse. So we map x and y into yx. Question? Rigonta? No? Is it muy frío or mucho caliente? I feel cool. I don't know. So, is it okay to close the door? Mija, can you close the door? It's muy caliente. Mucho frío. Okay. So, any question on this? So, can I turn this, or can I put this up now? You guys done? You guys done? Okay. So, an inverse function is a reverse mapping of the function that is f of a is equal to b. Then we have now the inverse. You don't have to read this as f raised to the power of -1, but you're gonna have to read that as inverse. Okay, when you come across with this f, then a power -1, you don't have to say f to the power of -1, but the inverse of the function. Okay, so is equal to a. Then another way of thinking of this is a function has a coordinate AB, then the inverse function has the coordinate BA. A while ago I put x and y, right? X and y, and then yx. So this is just the same as writing. This is just the same as writing. Okay, sorry. xy map to yx. So the function is increasing or decreasing. By looking at this one, we're gonna start from left to right. We're gonna analyze the graph from left to right. Start left and going to the right. Now, what is the smallest value of x right here from the left? Isn't it that the smallest value from this graph is -3? And then the largest value of x is 2, right? So that is the interval AB. Okay, how about right here in graph number 2? Same thing, the smallest value of x is -3 and the largest value is +2. Okay, so if the function is increasing or decreasing only, then it is invertible. What do you mean by invertible? It has an inverse. By doing, can you recall in Algebra 2 that you were doing vertical line test, whether it is a function or not? Once the line crosses only the graph once, then it is a function, right? When you do vertical test. And then this time we do horizontal line test. For horizontal line test, once the line crosses only one time, once in a graph, then we can say it has an inverse or invertible. So think of this as a horizontal line test. The vertical line test checks to see if the graph is a function. Remember, the vertical line is for you to check whether it is a function, because not all relations are functions. Okay, so we can say it is a function, such as this one. Let us say you have this circle. You're gonna test vertical line, then once this line crosses more than 1, okay, how many times the blue color crosses this green circle? Twice, right? So therefore our conclusion that this is not a function by applying vertical line test, because this blue color crosses how many times? 2 times, right? So this is not a function. This is just a mere relation. Okay, this is just a mere relation. And to do horizontal line test, checks to see if the graph's inverse is a function. Now we do horizontal line test. How many times the blue color crosses the graph? Just once, right? Therefore this has an inverse. Okay, invertible. And same thing with this, the line crosses only once. This has an inverse. Okay, so can I move this up a little bit? Okay, yes.
Why do you choose to put the line there?
This one?
Yeah.
We are on horizontal line test. We're gonna test if the line crosses only the graph once, then we can say that it has an inverse. Okay, But for vertical line tests such as this, if the graph crosses twice, then it is not a function. It's just a mere relation. This is just a relation. It's just similar to a boyfriend-girlfriend relationship. If you guys have only one girlfriend, so it is a function, one-to-one function. But if you, let's just, for the sake of discussion, if Anthony has 3 girlfriends, it is just a relation, right? There's no true love. Why? Because Anthony has 3 girlfriends. And you need to choose which of the 3. So if you have one-on-one relationship, it is a function. It goes back and forth. You love me, I love you. I love you, you love me. That is one-to-one relation, so it is a function. Right? So this is just same as like that. If you have a lot of girlfriends, if you have a lot of boyfriends, it is not love anymore. Right? No true love. Okay. Right, Jackie? Okay. So, it's Mutsu Caliente now. Can you open the door? Somebody has to open the door. Thank you. Okay, let's take a look on this one. Again, we're gonna do from left to right. Let us identify the coordinate. What's the coordinate of this one? Isn't it that it's gonna be -3? Oh. Okay. So this one is -3 and 1, right? Okay, so -3 and 1. And then what about this one? What about this one? What is this? Coordinate.
-1 and 0.
-1 and 0. So -1 and then 0. And what about this one? What is the coordinate? It's gonna be 1 and -1. So 1 and -1. How about this one? It's gonna be 2 and -3. So 2 and -3. So which means the blue color, the XY, is mapped into, I'm gonna use red color, Y, X. Get me, guys? So Y, X. Let's start on this one. So -3, 2, right? The Y, X. If we switch now X and Y, so this is now -3, 2. Where is -3, 2? It's gonna be right here, -3 and then 2. This is the inverse, right? You get me? Okay, next. 1, -1, this means
-1.
-1, 1. So -1, 1 right here. And then the next one. The next one. -1, 0. So this means 0, -1. 0, -1. So right here. And the last one. -3, 1. That means 1, -3. So 1, -3 right here. Okay? So I'm gonna use green color to have the inverse graph of this function. So the inverse graph of this function looks like this. Sorry. Okay, that is now the inverse graph. Any question on this inverse graph? Okay, next, number 2. So before that, this black graph is the graph of f of x, and the green graph is the inverse. So this green graph is now the inverse of x. Okay, here guys, now I need you to do by yourself for number 2. This is the graph of g of x. So I need you to identify or sketch the graph of the inverse. Okay, so by identifying this one, I need you to identify these points. Please have the coordinate of this. The next is at -2, and then we're gonna say at +1, and at the value of x +2. Identify first the points. I'll go around to check your work. Okay, Julia, sorry. Can you identify the coordinate of this, Miha? -3, -4. Very good. So this is -3, -4. Okay, and then what is the inverse? -4, -3. So let's take a look on the inverse. -4. So this is -4 and then -3. So this is now the inverse, right? Okay. The next one. Isaac, what is this coordinate, mijo?
The inverse? Or
This one.
Oh, that one? -2, -1.
-2, -1. And then, what do you think is the inverse?
-1, -2.
-1, -2. So we're gonna have to say -1 and then -2. This right here, right? Am I right, guys? Okay. And the next one, Calvin, what is the next one? What is the coordinate?
1, 0.
1, 0. Okay, 1, 0. So what is the inverse, mijo? 0, 1. So we're gonna have 0, 1. This one, right? Okay. The next, to identify, the last one is at the value of x equals 2. So this coordinate now is, yes, Jackie, 2,
3.
2, 3. Okay, 2, 3. And what is the inverse of 2, 3?
3 and 2.
3, 2. So we say 3 and then 2. This one, right? And then you're gonna connect all these points having this. Okay? So this is now the inverse. The blue color is the inverse. So the inverse of the graph of the function f of x can be found by reversing the rules of the x and y. So we're gonna switch. We reverse, right? xy into yx. So this means we can reflect the graph of f over the line y equals x. Remember a while ago, we have the line of symmetry, right? The line of symmetry. If I take the line of symmetry for this, the line of symmetry goes this way. The black right here is being reflected, that becomes blue. And the black right here reflected right there. Okay, that's the reflection. And this is the line of symmetry, which is y equals x. Same thing here also. You do line of symmetry. Okay, so is this clear, guys? Intended? Okay, so the domain and range of a function and its inverse are swapped. So what is the minimum value of the inverse of x? Now look at this. Can I move this up? I'd like you to look at this particular point. What is the coordinate of this?
-2, -3.
This is -2 and -3, right? Okay, next, how about this point? We're gonna have
3 and 4.
3 and 4. But what is the inverse? The inverse now,
4 and 3.
it's gonna be 4 and 3. You get me? And what is the inverse?
-3.
-3 and -2. Okay. Now inverse. A while ago we do x and y. Okay, x and y. And the inverse is y x. Pregunta. What is the minimum value? It's gonna be minimum value of the inverse function of x. What is the minimum value? It's gonna be
-3.
-2. So I need you to write the smallest value of x is -2. So I'd like you to graph first. We're gonna have -3 and -2. Okay. This is it, right? So the smallest value is -2. What about the maximum value of the function? Now we're gonna have this 4 and 3. So if x is 4, we're gonna have 3. Sorry. 4 and 3. I'm blind already. And then you're gonna have this, and of course the line of symmetry is right here, right? Okay, maximum. The maximum of, what's the max right here? 3. Okay, so xy into map into yx, so it has the largest value of 3. Okay, which means it is the value of y. Do you get me? Smallest value of y right here, the inverse is -2, and the largest value is +3. That's what it means. Okay, can we move this up now? So we're gonna do the next one. So we do the same function a while ago. This is the function that we were doing a while ago. So one method of finding the inverse function is to reverse the rules of x and y in the equation, then solve for y. So a while ago it was graphical, right? It was graphical. We graph. We interpret the graph. Was this tabular or graphical? Whatever. So the first thing that we discussed was tabular. Then next is graphical. And this now we do algebraic way. Now what is the rule again in algebra 2? Doing this, we're gonna switch x and y. But before switching, you're gonna change f of x first. F of x is just equivalent to y. Okay? So therefore we are rewriting this. Instead of writing f of x, we're gonna write this as f of x into y. So this is y equals x plus 2 to the power of 3 plus 3. Before I continue, is this clear now? So first we are changing or rewriting the f of x into the y. Okay? And what's the next thing that you do? We now switch the x and y, right? So I'll do another color. Since we are now switching, the y becomes what? X. And the x becomes y. Okay. So it's equal to y plus 2 to the power of 3 plus 3. And then after that, solve for y. So our next concern is to solve in terms of y. It says y equals. Okay? Solve for y. So how to solve for y? Investigate this first, that 3 is isolated, not part of the parentheses, right? Therefore, you're gonna move this 3 to the left side. Meaning, it's just the same as subtracting 3 both sides. But do I have to show you to subtract 3 both sides? We can do mental math right away. I'll just use law of transposition. If I transfer positive 3 to the left side, what happens to positive 3? Positive 3 turns to
Negative.
negative. Okay? So, this means x minus 3 is equal to y plus 2 to the power of 3. Okay. Now, this doesn't have power, or it is understood to be 1, right? If I do parentheses on this one. So, in order for us to eliminate the power 3 right here, because we are solving for y is still inside the parentheses. So we want to set y free. Y has to earn a freedom. I'm free. So we're gonna multiply both sides by 1/3. Okay? Or some other students will say, can we cube root that one, Mr. Roy? Yes. Okay? But I'm showing you the step. Okay? That if we multiply now 3 times 1, it's 3. Divided by 3 is 1. Do you get me? So rewriting this again, that the left is now x minus 3 to the power of 1/3. Okay? And the right side now is y plus 2 to the power of 3 over 3, which is 1. Okay? So, what is 1/3? Power 1/3. It's now cube root. Very good, Paulo. So this is cube root of x minus 3. And am I now safe to write y plus 2? Because 3 over 3 is 1. Can we now isolate the y? right? So what to do with this 2? Move this 2 again to the other side. Okay? So it's gonna be cube root rather. Cube root of x minus 3 minus 2 is equal to y. Or for me, I'm comfortable writing y equals. It's just the same. The cube root of x minus 3 and then minus 2. Please make sure to write negative 2 outside from the radical. Okay? Next, although partly this is the answer, but in the actual AP test, the options are not written this way, but the options are written like this, the inverse of x. And this will be the final answer. The cube root of x minus 3, then minus 2. This is the final answer. Okay? If this is free response question, if your answer is until here, so you are not getting the full 3 points. How much points will you receive? It's only 2. Okay? You're gonna have to write it this way if this question falls on free response. Okay? So, and a question for number 3. Do we still have time? How much time is left?
Like 5 minutes.
In 5 minutes?
Yeah.
Okay. Can I move this up? Is 5 minutes enough for this problem? I don't think we can finish. So, can we just continue the lesson tomorrow? Okay?
Excuse me.
Jackie.